Okay, now we're talking about section 14.3. We're going to look at 9, 11, 13, and 19. They're all B-level problems. Okay, so 9 says this. Where does the glide reflection in exercise 7 map XY? So the glide reflection in exercise 7 took a point, it moved it straight up 4 units, and then it reflected it over the y-axis. So if I take my point here and I move it straight up, the x's stay the same, and I add 4 to the y's. So I go from x, y to x, y plus 4. So that's the first mapping. This is my glide, or translation. Now the second mapping is a reflection over the line over the y-axis. So there he goes. You can see that when I reflect, the y's stay the same. It's on this same line here. But the x's switch signs. You know, they go in, they come out. Go in perpendicular, come out the same distance. This line of reflection cuts this point, or cuts this segment in half. So my y's stay the same, so you can see that there. But my x's change signs. All right? So in this case here, we have the point xy. It ends up at negative x, y plus 4. All right, so that's the first problem. The second problem, 11, says that which of the following properties are invariant under a translation? So invariant means they are preserved. Okay, they don't change. They're invariant. So a translation is an isometry. So because it's an isometry, it preserves distance, angles, and areas. And isometry also preserves orientation. You know, now look, this is a terrible picture, but pretend I copied and pasted this little guy here to this little guy here. You can see that the orientation gets preserved because all I'm doing is I'm just shoving him around the plane. All right? I don't reflect him. He doesn't change orientation like reflections do. All right? When you can translate something, i.e. shove it around in the plane, it preserves orientation. So the answer to 11 is A, B, C, and D, distance, angle, measure, area, and orientation. Okay, 13 is kind of a fun little problem. All right, 13 gives you, they describe two translations. R maps point P to P prime, and what R does is it takes a point, x, y, it adds 1 to x, it adds 2 to y. And then you take that point, and then you're going to apply a second translation, and what S does is it takes 5 away from x and adds 7 to y. And we want to know in the final analysis what happens to your original point. So what I want to do is I want to show you concretely, and then we'll talk about the theory. So take this point 2 here, 2, negative 1. And so what the first translation R is going to add 1 to the x, so it goes from 2 to 3, and it's going to add 2 to the y. So the y value, negative 1 plus 2, gets me 1. So this point here, 2, negative 1, gets moved under this mapping R. It gets moved to 3, 1. Okay, now what's going to happen is I'm going to apply the second mapping S. So I'm going to move this point, okay? So here's the pre-image, and here's the image under R. Now, this point becomes the new pre-image under S. He gets mapped to the image of S. All right? So this is the pre-image of R. This is the image of R. But now he becomes the new pre-image of S, and here's the image of S where he ends up. Okay, so S, what S does is it takes away 5. All right? And so that one goes from 3. If I'm going to take away 5, my x value is negative 2. And then I add 7. So to the y, if I start with a y of 1 and add 7 to that, I'm going to end up with 8. So what I want us to notice here is starting from here, my starting point and my ending point, You go from 2 to -2 in the x's. So you're subtracting 4 in the x's. And I go from -1 to 8 in the y's. So I'm adding 9 in the y's. So take a look at this. X plus 1, x minus 5. When I put them together, you can see I end up subtracting 4. Here I have plus 2, plus 7. When I put them together, I add 9. Okay? And, if you want to think of this like a vector, this is a line here going from this point to this point to this point. This composite transformation here is really the sum of the two vectors. All right. Number 19 was the last one. Explain why a glide reflection is an isometry. Again, I'm not going to do a proof. This is just going to be kind of a casual explanation. Okay, a glide reflection is an isometry because it's a composition of two isometries. A glide is an isometry. That means it preserves distance, angle, and area. A reflection is an isometry. It preserves distance, angle, and area. So when you put the two together, if you glide first and then reflect, it's also going to be an isometry. Preserves distance, angle, and area. All right, that is it for now.